We're starting Unit 2, which is all about polynomials and rationals, and we are going to start with power functions. Super short little section here. The power functions are actually monomials. So a power function is any function in the form of f of x equals a times x to the nth power, where a cannot equal 0 and n cannot equal 0. Because if a equals 0, then the whole thing is just 0, right? And if n equals 0, what is anything to the 0 power? 1. Anything to the 0 power is 1. So then we lose our variables kind of either way. So this is just a one-term thing, okay? So it's just like 3x squared, not 3x squared plus 7x or anything like that. And so a power function, like I said, power function is a monomial function. And we're going to draw a sketch of each of the following monomial functions, which some of these are the same parent functions that we've been looking at. So if our constant function is just f of x equals c, where c is a number, no, not a variable, and that would make that a horizontal line, so it could be anything, and we could just make it look like this. Okay. Linear, we know, is f of x equals x. So that is your y equals x line that looks something like that. Quadratic, we should definitely know f of x equals x squared. That's your parabola. Cubic, f of x equals x cubed. Looks something like that, right? Then we have quartic, that is f of x equals x to the what, do you think? Fourth. And then quintic, f of x equals x to the fifth. Okay. So I know you know what those graphs look like already. Do you know what a quartic looks like? And that may not be something you've learned. I'm not sure. That's why I'm asking. Anybody just know without guessing? It's all good. So let's think about this then. If I have, let's just put in our, kind of do it like a parent function thing. If I substitute in 0, I'm going to get 0, right? If I substitute in 1, I'm going to get 1. If I substitute in negative 1, what am I going to get? What's negative 1 to the 4th power? 1. So I'm up here at 1. Then 2 to the 4th power. So if I go to 2, 2 times 2 is 4, times 2 is 8, times 2 is 16, right? So I'd have 2, and then I'd be up here at 16. Negative 2, where would I be? 16. So what do you think that's going to look like? It also looks like a parabola, okay? And that's how you kind of figure it out if you're not sure. But a quartic, it really ends up being like a skinnier parabola, because instead of being at 2, 4, we're at 2, 16. We're way up there, right? So given that, and so they almost look identical right here because we don't really have a scale because we're not putting numbers on there. What do you think the quintic would look like? Not like a parabola, because if I have 1, I'm going to get 1. If I have negative 1, what am I going to get? Negative 1 to the 5th power? Negative 1. So it's going to look like the cubic. So basically, when you have power functions, and only power functions, okay, not any polynomial to that power, that all of the even ones, if it's just one term, all of the even ones look like a parabola. All of the odd ones look like a cubic, every single one of them, okay? So once we know up to cubic, then we pretty much got everything else, right? It's just skinnier because it gets, bigger and smaller faster. Okay, so let's talk about, and again, this is just talking about our monomial functions, not any function in general. If the function has an even power, so our even powers being the quadratic, and the quartic on here, if that is true, then if the function has an even power, then it is symmetric to the y-axis. Okay? If we have an even-powered power function, it's symmetric to the y-axis every time. Okay? Even after transformations, because since it's a monomial, we're not going to have any translations left, right, up, or down, because that's when we have to add and subtract stuff. But we can stretch it, because that's multiplying, or squish it, either way, or reflect it. And so if we do all that stuff, shrink, stretch, and flip, it's still going to be symmetric to the y-axis. Okay? And then we have the odd powers. So our odd powers are linear, cubic, quintic. These are, so it says if the function has an odd power, then it is symmetric to, now it doesn't have line symmetry like the parabola does, but it does have rotational symmetry. Okay, I can take this and I can rotate it 180 degrees and then it would look the same, right? So basically if you took your paper and flipped it over, the graph's going to look the same. So that means that it has point symmetry about the origin. Okay. So the odd power it's symmetric to the origin. Okay. Then we're going to talk about end behavior again, okay? Because we're going to talk about end behavior a lot. And we're going to get to a point where right now we're going to use the words again, like the little sentences, but then we're going to kind of bypass that because we're more concerned with visually what's happening because we're about to start sketching polynomials. So if I have an even-powered positive coefficient, so f of x equals x squared or x to the fourth or x to the sixth, whatever, then I know it's going to look like a parabola. So that means that as x approaches infinity, what does f of x approach? Infinity. And as f of x approaches negative infinity, as x approaches negative infinity, f of x approaches infinity again, right? Even power negative coefficient means I'm going to be reflected down, whether it's x squared, x to the fourth, x to the sixth, whatever. Then this is what my end behavior looks like. So as x approaches infinity, f of x approaches negative infinity. And as x approaches negative infinity, f of x approaches negative infinity again, right? All right, so odd power positive coefficient, x cubed, x to the fifth, x to the seventh, whatever. As x approaches infinity, f of x approaches infinity. As x approaches negative infinity, f of x approaches negative infinity. Then when we have an odd power negative coefficient, it gets reflected, so these switch places. So as x approaches infinity, f of x approaches negative infinity. And as x approaches negative infinity, f of x approaches infinity. Okay? We good? What questions we got? So remember, this is just about end behavior. Tomorrow, we're finally going to start looking at some middle behavior, but we're just still talking about end behavior at this point. Any questions at all? Okay, we're not even going to graph on the back. We don't need to. Okay, all this was to introduce you to power functions. Let's talk about end behavior again, and then we'll look at some polynomials tomorrow. Okay?